First thing I'd like to say is a bit of a thank you to the organising committee for suggesting I come up here and give this presentation. And it's based largely on the fact that we had, as I'm sure a lot of you will remember, we had pretty wet conditions through November and December. You're trying to harvest your crop and the rain just keeps on coming. So what we're looking at is it possible to use some of that moisture for something other than evil? Thanks to the organisers and thanks to my co-authors, Yvette Oliver and Nadine Hollenby, who've done a lot of work in the Northern Ag region. But I'll be pulling together results from as much as I can right across Western Australia. We'll get into it. So first of all, how much rain did we have through November, December, January, and what are we looking at from here on in? You can see through November, pretty wet through the eastern wheat belt, the south coast and the west coast. December, once again, not a whole lot, little bit of spot there in the eastern wheat belt, and again in January, the eastern wheat belt's looking like it's copped a fair bit of summer rain so far. How much is that rain worth? So what I'm going to be talking about today is how much of that rainfall are we likely to store in the soil, how much is still going to be there on May the 1st. I'll be looking at the effect of residue management on how much water is left in the soil, and I'll be looking at the effect of summer weeds and how much water summer weeds are taking out and what they're doing to water and to nitrogen as well. Finally, we'll be looking at how much, what impact that's going to have on crop yields going forward. Okay, so first of all, looking at summer rainfall storage. Our fallow efficiency is normally looked at along the lines of how much rain do we get over summer and how much is left in the soil, and it doesn't seem to matter where you measure it in Australia. It's around that 30% mark. So if we get 100 millimetres of summer rainfall, we'll keep about 30 millimetres in the soil. Now obviously that varies a fair bit depending on what time the rain comes down, depends a fair bit on soil type. What doesn't seem to vary very much is where you are in Australia. So that 30% number is reasonably robust as a long-term average, but obviously from year to year things change a fair bit. So let's have a look at that. So on this graph I'll put up a number of results looking at what happens with different amounts of rainfall coming in the middle of different months. So in this particular example, I've said let's look at 25 millimetres on a sandy soil. If we get 25 millimetres coming in the middle of November or December or January, none of it's still there on May the 1st. But if we get 25 millimetres later on, we might store 7 or 8 millimetres. So 25 millimetre rainfall event on a sandy soil isn't going to do you much good. What if we get a bit more than that in a single rainfall event? So if we go up to 50 millimetres or 100 millimetres, you can see even if we get that early on, so in November, December, January, we're still looking at we lose about 30 millimetres and keep the rest. So if we get 100 millimetres, we keep 70. If we get 50 millimetres, we keep 20. And it doesn't seem to vary very much with the time of the rain, the time the rain comes down. So even if we get it in the middle of April, 2 weeks later on the 1st of May, most of the evaporation that's going to happen will have happened by then. That's on the sandy soil, and that's because the sandy soils really don't have a lot of capacity to store rainfall close to the soil surface. So once it gets down below about 30 centimetres, it seems to be pretty safe. What happens on a clay soil is a little bit different. You see, first of all, a clay soil, we lose a lot more water by evaporation straight up. But there are a few similarities here. Firstly, November, December, January, February, all about the same in terms of the effectiveness of that summer rainfall. On the clay soil, if we get 25 millimetres of rain, it's not going to do us very much good, no matter when we get it. 50 millimetres of rain, we can store as much as 20 millimetres of that if it comes late. If it comes early, we're going to lose most of that as well. But for a single rainfall event of 100 millimetres, we might be able to keep as much as 60 millimetres of that in the soil on the heavier soil. And the reason that the heavier soil is not so good, or loses a fair bit more water than the lighter soil, is because more water gets stored in that top 30 centimetres. So we need to get bigger rainfall events to get the water down out of reach of evaporation. So here's a real example of measured soil water contents. This is for Kojonup. It's not a sand soil or a loam soil, it's somewhere in between. So we'd expect to see something sort of in between those results. This was the summer of 2010-11. Pretty wet November here, 40mm rainfall event, and yeah, yes, soil water storage jumps up pretty reasonably and then seems to stay up there, which is not what I was expecting at all. But having seen those modelled results, it does look pretty reasonable. Another 40mm rainfall event. Big jump in soil water storage to that point there. Now here's a demonstration of something else, where we do get rainfall events followed closely one after the other. They can be additive. So here we've got a 40mm event, a 20mm event, and you can see they've both had an impact there. So they're adding one on top of the other. But where there's a longer time period between rainfall events, so I've got this 20mm event here, that's done essentially nothing to our soil water storage. But overall, for this particular summer, we had 200mm of rainfall, and we've actually stored nearly half of that in the soil, which is interesting because a lot of that came early, but we still managed to keep it in the soil. And I remember talking to farmers at the time, and they were saying, bemoaning, we were into May, and it was pretty dry in May. And the farmers were saying, oh, it's so dry, we need some water to get the crop up. I said, well, you probably do need some water in the top 10 centimetres to get the crop up, but after that, your soil's pretty wet already. You're going to have troubles with waterlogging this year, and that's the way it turned out to be. So there's an example of what how summer rainfall can be stored in the soil, and sometimes you can get quite a lot of it in there. So if we're looking at how much summer rain can we store in the soil, there's a few simple rules. One is the first 20-30mm, forget about, it's not going to do anything for you. On a sandy soil, if you can get rainfall events more than 30mm, you'll keep the rest of it in the soil. On the loamy soil, if you can get rainfall events more than 30mm, you'll keep about half of the extra in the soil. So on a loamy soil, if you get 100mm of rain, you lose 30, straight away that's 70, and then you keep about half the rest, so you keep about 35mm. So those are simple rules for storage of summer rainfall. How much are you going to keep in the soil? Let's have a look now at what impact residue management might have on how much soil water you can store over summer. Now I have some modelled values here for the Northern Ag region, so thanks to Yvette Oliver for these numbers and Nadine Hollenby. They're not very big numbers. This is the difference in stored soil water. So if we had 3 tonnes of residue as against 50 kilos of residue, how much difference would that make in soil water storage on May the 1st? And yeah, up to 4mm. That's not very much. So in terms of residue management, how's that going to impact on water storage over the whole of summer? That's pretty much the end of the story. It's not going to have much of an impact. We have some more measured values. They were modelled values, so perhaps the model was wrong. We've got some measured values here for our site at Cunderdin. This is in collaboration with the No-Till Farmers Association. And we have quite big ranges, so within the summer of 2010-11, quite a big range of residue from less than 2 tonnes up to 8 tonnes. And what we'd hope to see is a line going that way, so that with more residue, we'd have more stored soil water, and we certainly don't see that. And the same with the 2011-12 summer. Big range of different residue quantities, no consistent impact on soil water storage. Now, just looking at it from a slightly different perspective, that's looking at soil water storage over the whole of summer, so residue management, not much impact there. We can look at it over a much shorter time period. And here's some measurements we've made from a site down at Munglanup, where we were down there, as it happened to be, just about a week after 74mm of rain, so quite a decent dump of rainfall. Where we have our, where we have our no-till stubble retained, quite high soil water contents a week after our rainfall. So where we've retained the stubble, higher soil water contents, particularly in the crop rows. That's because we've left the residue standing, rainfall hits it, slides down, soaks in there. So we can get pretty good soil water storage where we retain residue. Where we've got rid of it, we're down around 4% soil water. Where we've kept the stubble, we're up around 6% soil water. Doesn't sound like a very big difference, but that's the difference between being able to seed and not being able to seed. So that's a pretty useful difference to be able to keep. If you can keep that for an extra few days, that's useful. Obviously you're not going to do that in February, but that's the principle we're looking at. A similar sort of thing here with our trial at Cunderton. We happened to be there measuring evaporation rates. This is just fortunate again, we'd planned it 3 weeks ahead, and the night before we got there, 20 millimetres of rain. So fantastic. Good measurement of evaporation rate at midday, just from your normal stubble, or with a cover crop residue, where it's been rolled flat, lower evaporation rate than from a regular wheat stubble. So again, by managing stubble, you can have an impact in the short term on soil water storage. So while I've said residue management has no impact on long-term soil water, it can have an impact in the short term, and that can be really useful if it happens at the right time of year. So I'll just summarise that. I think I just said it then anyway. There is a limited impact of residue on soil water storage over the whole of summer. If you do leave standing residue there, that can encourage infiltration to depth and keeps extra. If you can get the water down deep, it's more likely to stay there. And residue may help to extend your sowing window by as much as a week, and that can be a really useful thing. And there's a whole lot of recent research on residue and soil water content through the GRDC Water Use Efficiency Initiative right across southern Australia. And I think in over about 20 different trial sites, there's only been one where residue has been found to have a significant impact on soil water storage over a whole summer, and that was somewhere in central New South Wales. So in all the other trials, residue and total soil water storage over summer, bugger all impact. Now let's look at summer weeds. And I'm not a weed expert, and when I started looking at this, I thought I'd just get onto the internet, do a bit of a search and see what I find. Summer weeds, soil water storage, there's got to be a whole heap of knowledge out there, and it turns out there isn't. So I'll put up all the data I can find, but if anyone out here knows of anything else, please let me know. So I have some modelled values, again thanks to Nadine and Yvette for using these. This is average over the long term. What difference do summer weeds make on soil water storage? Again, they're not big numbers. For residue, we were looking at 2s and 3s. Here we're looking at 7s and 8s. So, yeah, twice as much long-term impact of summer weeds compared to residue. So they do have more of an impact than residue management, but this is the summer weed story. It's pretty difficult to model summer weeds because there's so little data on them. So we don't know root distributions, we don't know patterns of water uptake. But now, so on our 4 different sites up in the northern ag region, 4 different soil types, yeah, reasonably small, but can get the long-term impact. So that also includes years where there was no rainfall and includes years where there was lots. But yeah, so we're getting to 10 millimetres starts to become a useful number in terms of soil water storage. There are a few measurements made at Merredin from summer weeds and the impact of soil water storage. This was a really neat trial. It goes back a few years, obviously. Abul Hashim was involved in this, so thanks to him. There was, the 4 main treatments. One was irrigated to try to encourage the summer weeds. So irrigated and summer weeds controlled, or irrigated and left alone. And the other one was just natural rainfall, and whatever weeds came up were either sprayed or not sprayed. So for our 2 treatments, we'll firstly look at where it was irrigated. And this is the increase in soil water as a percent of the initial value. I'm not actually sure what that means, but that's the number that's published, so I'll have to go with that. Not much of an increase in soil water over the summer, even where it's been irrigated. So that's interesting. We've had a lot of irrigation go on and not much of a change in soil water in this case. But where things weren't irrigated, where the weeds were controlled, you've actually doubled the increase in soil water. So the weeds there are having an impact on stored soil water. And that's the only thing I could find about summer weeds and stored soil water. That's what I mean by there's really not much out there. They also measured nitrogen, which is actually really good. Again, the same 4 treatments. And this is looking at the increase in stored soil nitrogen over the summer period. And that's really important because if you do get wet and warm conditions, like happens with summer rain, that's really good for mineralising nitrogen. That's where you get the big burst of nitrogen coming into the soil. Where we've had a ton of, caltrop mostly, that has actually sucked nitrogen out of the soil. So instead of starting the season with a whole swag of nitrogen in there, we're starting with less than we had before. Where the weeds have been controlled, a big increase in soil nitrogen. So that's a big turnaround. Where the plots weren't irrigated and we just left a summer rainfall, again, the same sort of thing. With weeds, not much of an increase in soil nitrogen, but where you control the weeds, a big whack of nitrogen available. So that's probably more important than the water side of things in terms of summer weeds. So just a quick summary on the summer weed story now. They are likely to impact on soil water storage, but we really don't know much about it at this stage. We can speculate that deep-rooted weeds are more likely to reduce the soil water storage than the shallow ones, but even that, we don't know which plants are deep-rooted. In the full paper, I've given an example of paddy melon as a shallow-rooted weed, and the weeds people say, oh no, that's deep-rooted. You try to pull one up and the root breaks off. But the ones I've pulled up in sandy soil, I can go for a very long walk pulling this big taproot, and it just goes this far under the soil and just keeps on going. So even in terms of the common weeds like that, we're still not sure about what the actual root distribution really is. We don't know a lot about their germination characteristics. So we don't know how much rain is going to take to get them to come up. Obviously, it's a matter of just looking at the field and seeing if there's summer weeds or not. Now, what's going to happen with crop yield in terms of all those things I've been talking about? There was a paper published 2 years ago now. Did a very good study on the impact of summer rainfall on crop yield. What's the contribution of summer rainfall to fallow, or what's the contribution of summer rainfall to subsequent crop yield? And this is modelled over a number of different locations within the Western Australian wheat belt. What I really want to concentrate on here, this is the column of crop yields with summer rainfall. And this is where you just run the same model, but don't have any summer rainfall in it at all. And these are long-term average crop yields. So if we're looking at, in particular, the wet sites, so the Minginoo, Wongan Hills and Borden, there's almost no change in crop yield. So whether we include the summer rainfall or not, it doesn't have much of an impact on crop yield because it's a wet region and there's enough rainfall within the season to get your crop up to its maximum potential anyway. In the drier parts, say Bunteen, Morawa, Kellerberrin and Salmon Gums, you can see there's half to a tonne of the crop yield you get there is actually due to summer rainfall. So what that's saying is that if you're in the drier part of the wheat belt, it's really important to keep hold of soil water. This isn't rocket science, folks. In the wet parts of the wheat belt, it's not so important to hold on to your summer rainfall. They also modelled profit. This is pretty interesting as well. So in those sites where there was a big difference in yield because of summer rainfall, funnily enough, that's where you get the best bang for buck by controlling the summer weeds. Interestingly enough though, it doesn't matter where you are, there's always an average positive response. Sometimes it's not very much, but it is always positive, even though, so this, come back a step, this is the percentage of years where they reckon summer weed control is going to be necessary. And the way they worked that out was to look at 25 millimetres over a 3-day period. If you've got 25 millimetres over 3 days, that'll be enough to get summer weeds up. That's a guess on their part. I'm not sure if there's any real data on that. And you can see in the northern wheat belt, less than half the time. As you go further south and east, it becomes more common. So Borden, Salmon Gums are over more than half the time. There will be a summer weed germination, so it's worth thinking about spraying the summer weeds out. Now, the percentage of those years where it was actually necessary to spray summer weeds, how often was it profitable? And that depends a whole lot on the yield benefit you're likely to get. So in the wet parts, so Minginoo, Wongan Hills and Borden, you're scratching around between a third of the time and a half the time it's going to be profitable, which means half to 2/3 of the time it's not going to be profitable in that year to spray out summer weeds. As you go to the drier parts of the wheat belt, the story changes around completely. So that for Bunteen, Morawa, Kellerberrin and Salmon Gums, 3/4 of the time it is worth spraying summer weeds out. So there's some reasonably simple guidelines there. Now they were modelled, whereas it's actually been measured. There have been a few trials looking at dumping extra soil water on at sowing time to see what impact that has on yield. And these have been done in the northern ag region again. So the only significant impact was at the New site last year. Where we go from 2 tonnes to just over 3 tonnes by putting extra water on at seeding. So if there was an extra 30 or 60 millimetres of water in the soil, that'd be useful. But on these other occasions, the other 3 occasions, Bunting, Moora and the other soil at Delhi, no impact of extra soil water on crop yield. Again, there's not much data on this really. We come back to the trials mentioned earlier at Meriden, the summer weed trials, and the impact that extra soil water's had on crop yield there. Generally, Meriden being a dry part of the wheat belt, we'd hope to see a bit of an impact, and generally there is. Quite a difference there, a little bit of a difference there. 2004 was obviously pretty dry anyway, so not so much happening there. And a little bit in 2009 as well. But the other thing, I was saying before, these Meriden people measured soil nitrogen, which is fantastic. Big increases in grain protein through controlling summer weeds. Not so much there, but all the other times where it's been measured, increases in grain protein, so that's probably worth chasing. The nitrogen side of summer weed control, I think, is more important than the water side. So let's come back to our key messages now. Single rainfall events greater than about 30 millimetres can contribute to stored soil water. Summer weeds will use stored soil water, that's how they grow. And they will impact on water and nitrogen availability. Summer weed control is usually a pretty good idea in the drier parts of the wheat belt, but not so much in the wetter parts of the wheat belt. And there's still really not much known about summer weeds. So if I was to distill it all down to a simple question, is it worth controlling summer weeds? The simple answer is, of course, it depends. That's always the answer. But it does depend in fairly predictable ways. If it's a dry part of the wheat belt and you're expecting a dry year, it's certainly worth getting on top of the weeds. If you're in a place that often gets waterlogged, perhaps summer weeds are a good thing. Anyway, I'll leave it there. Thank you very much.